Hello, folks. This is chapter 22 in our book, and today we are looking at glaciers. Um, this is one of those chapters that's just absolutely fascinating to read. I guess because we know that glaciers exist now. We'll talk a little bit about how that came about, but just the fact that you can still go and see glaciers, but to imagine that entire continents were covered by glaciers, and not just covered, but covered by miles deep. I mean, just think, look up in the sky and think a mile high is where the ice used to be. It's a pretty amazing thing. So it's a really interesting chapter to read. Plus, it's there's a lot of evidence. Once we know kind of what to look for, you can kind of look and see places, and some places not very far from here, that look the way they do because of the last ice age, which was not that long ago. Um, well, we're going to get into that. But the last ice age was only 12,000 years ago, and that's about the time when modern humans began to settle down and grow crops and raise animals and what we think of now as civilization. So literally civilization starts, modern human civilization starts as the last ice age is receding, the last glaciers are receding. So it is kind of a fascinating connection between human history and the earth. So let's jump right into ice ages here in your book. And so again, the first section here does talk about the fact that you know modern humans had not seen ice covering continents, and so but we saw lots of evidence, things that didn't make a lot of sense. And again, this is where a lot of great science happens: is you see evidence of something, and you start to put the pieces together, and you come up with an idea that's kind of so bizarre. I mean, that's kind of what Wegener did. If you remember, thinking about continents moving, just it's just such a bizarre thing. Well, can you imagine ice covering entire continents? I mean, that's just unimaginable. But the evidence was all around, and so like the theory of plate tectonics, this idea that glaciers could cover the Earth took some time to develop, but the evidence eventually became overwhelming. And some of that evidence is like these what we call erratics now, and they're basically just boulders out in the middle of a field. And there's these rocks came from many, many miles away. And so the question is, how did they get here? Well, uh, they could have been dragged here by ice. It could have been giants picking them up and throwing them. Of course, you can imagine the stories that people would make up. But the science is kind of overwhelming, and so this is kind of where this theory comes from. Is the idea of looking at what we see as glaciers, and then imagining that on a global scale would form a lot of these ideas. So anyway, we look at your book looks at something very simple, like what is ice? If you've ever thought of that before, of course, ice is basically just frozen water, right? But it's unique in that when the molecule H2O freezes, it forms a crystal lattice, and so it actually gets larger in volume and therefore will float. Most things that get cold, the molecules contract and it gets smaller in volume by keeping the same mass. Therefore, it would become more dense. Water actually becomes less dense as it freezes. And so we get ice that floats rather than ice that would normally sink. So glaciers are simply ice that moves by gravity. In other words, glaciers develop up high in mountains or high areas, and then as snow falls, that snow gets compacted, and over years and years and years, that compaction of snow turns into ice, as you can see in these pictures. And that ice then begins to flow down the mountain, similar to what toothpaste would look like, I guess, if it was flowing down a piece of cardboard. It just goes very, very slowly, but does move over time. And so this is how they form, and these are the glaciers we see today. What few that we have left. So you could be looking at, by the time you get to the bottom of a glacier, where it's ending, either falling into the ocean or melting. That ice could be, you know, thousands of years old. And so this has been a real boon for some scientists who study the Earth that long ago, because locked in this ice is little pieces of atmosphere, little balls of frozen atmosphere. And so we can go back in time thousands of years and measure. You basically get a core sample of ice. You melt the ice. What's left as a gas is literally atmosphere from thousands of years ago. We can look at what gases were there. We can look at the amounts of the gases, ratios, that sort of thing. And you can tell a great deal about what the Earth was like just by looking at this ice. So your book goes into a lot of detail here. And again, I don't expect you to memorize all this detail and all these new words and stuff, but it is important to look at just a couple of things. Um, for example, the idea of sublimation is when water, excuse me, when water or any kind of liquid evaporates directly into, or excuse me, a solid um, evaporates directly into a gas and doesn't turn into a liquid. Now, water generally does that, but occasionally it will sublimate. Excuse me. One of the most famous of these, I guess, would be carbon dioxide. And when carbon dioxide is frozen, we call it dry ice. It's called dry ice because carbon dioxide will sublimate. It will go from a solid directly to a gas and not be a liquid. So you can have a block of ice of CO2, and unlike water ice, where when it melts you got a big pile of water, carbon dioxide wouldn't do that. But anyway, um, so we have different kinds of glaciers. Today we have mostly mountain glaciers or alpine glaciers, which are smaller and exist in mountains. There are a few continental glaciers still around. They are in Antarctica and Greenland, but they're certainly much smaller than the glaciers we think of when we think of the ice ages. And again, this ice, it's kind of weird to think of this huge mass of ice moving, especially over an entire continent. But you've got to imagine that this ice is, even though it's solid, it's in a plastic form. In other words, it is able to shift and change and move, uh, and by what we call plastic deformation, uh, on such scales that we you don't normally think of it when you think of ice cubes. If that makes sense. Ice cubes are pretty solid and pretty stable, but ice over thousands of miles and kilometers deep can be very plastic, especially thinking of that massive weight and the force that's propelling them either down a mountain or across a continent. It's pretty amazing. So anyway, here's some pictures of some glaciers. Um, and again, your book's a little bit dated here because some of these glaciers are almost melted away. They talk about a national park up north called Glacier National Park. And if you want to see glaciers in Glacier National Park, you better go pretty quick because of climate change. A lot of those glaciers are going away. So you might definitely want to get up there quickly if you want to see an actual glacier. They are really cool. I got a chance to stand on one, a mountain glacier at one time, and it's just unbelievable to think the ice you're standing on is thousands of years old. That was snow a long time ago. It's got this iridescent blue color to it that's just quite amazing. So if you ever get a chance, that's definitely a trip you should take up into Alaska or up into Canada and see some of the last glaciers that we have. So here are these continental glaciers we talked about. So the only two places really on Earth that we have large amounts of ice on land is Antarctica in the South Pole and Greenland up north. Greenland um, is an island, and it is covered in ice. And so as this ice is melting, this is what the ice that we're worried about. that will literally raise the level of the ocean if it does completely melt away. Of course, there's a lot of ice on Antarctica too that would do the same thing, but most likely a lot of this ice would melt first, and that's a real worry for climatologists that are looking at this thing. So then they go into lots of names again of different parts and stuff, and you should definitely read it. But again, I wouldn't commit it to memory. Um, we know there's ice on other planets. If you've read any newspaper articles lately or any science articles lately, you know that one of the exciting things that happened about 3 weeks ago to a month ago was the discovery of more ice on the moon. Um, and so we've known for a long time that there's ice on Mars. You can actually see it. If you look at Mars through a telescope, you can actually see little white spots on the top and the bottom, and that is the poles. That is frozen water on Mars. So that's kind of cool. Um, but the most exciting news has been finding water on the moon, more water on the moon. We knew there was a little bit there, but finding more is kind of cool. So your book kind of goes through the mechanics here of glaciers, how they move. Um, Again, very slowly, based on just the sheer amount of weight and snow that develops. You kind of wonder, well, how can it move over a continent? I can understand it kind of moving down a mountain. Well, here you can imagine snow building up at some point and literally the ice moving out over a continent. So that's essentially what we're talking about when we look at these ice ages. We're talking about um, ice and snow developing to such a point that it literally, under its own weight, will move out, similar to taking a pool of honey and putting it down. The honey would kind of mound up for a while, but eventually it would begin to ooze out. And that's what we think of in terms of the way these continental glaciers move. And then there's some mechanics here on how these glaciers form different land features that we'll see. Glaciers that are moving forward uh, uh, are accumulating snow and pushing forward and advancing. Glaciers like up here where the glacier is going away faster than it's being fueled would be a glacier that's in retreat. And so most of the glaciers, again, because of climate change, most of the glaciers are in retreat. Um, and we would normally, again, not see that except for other changes. And we'll talk about some of the details of that as well. Um, it's hard to imagine that the ocean would freeze. We normally think of salt water as something that doesn't freeze, but if it gets cold enough, salt water will freeze. And so we'll see these glaciers in the sea itself. Um, Antarctica, of course, has these large ice shelves. And we saw one of the largest ones a few years ago break up, which was very disturbing to climate scientists for lots of reasons. And we'll talk about that more in the next chapter. But um, this just goes to show that these ice sheets can move not only across the land, but the ocean wouldn't stop them either. And so they would continue across ocean and land. So what do they do to the Earth? You can imagine several kilometers or a mile of ice, right? How much weight that would be. And as it's moving, it's literally like a big bulldozer grinding away at the Earth. And so a lot of erosion happens because of glaciers. And so we can see the results of that. One of the places that these glaciers stopped was right here near Louisville, right here in Kentucky. And so, literally, here in Louisville, you're living or the school is built on till or kind of leftover material brought down by glaciers. The last glaciers is about 12,000 years ago. And we'll talk a little bit more detail. But the Ohio River didn't exist 12,000 years ago, but only existed because as the glaciers came down, they literally pushed the river down and connected it to where it is today. And so it's a very different place. Also, you can see evidence by looking at mountains and some valleys. You can look at the rocks. And again, we've talked about this a little bit already because this was some of the evidence that Wegener was, using to prove that continents were moving, uh, was to see these striations, these scratches in the bedrock where the glaciers had literally run over them and scratched them like someone with rough shoes scratching a wood floor. Excuse me. And so you see these in lots of places. One very strange place is in Central Park in New York City. You can see some of these striations. So there is lots of evidence, and your book goes through a little bit more detail of that. And like I said, there's evidence right here in Kentucky because the glaciers literally stopped right about where the Ohio River is. And so a lot of the material that's in this area was brought down by the glaciers from hundreds of miles from the north. Um, here's a valley in Alaska. It was formed by glaciers. Here you can see another valley where it's cut. And the kind of shape we see is kind of this U shape. You can imagine all that ice uh, being in there and just kind of literally coming through here like a bulldozer with a U-shaped blade and just kind of carving away. Also up north, if you've ever gone up north, Indiana, um, northern Illinois, Wisconsin, those places, I mean, they have no mountains. I mean, the glaciers literally leveled everything up there. And we see Minnesota with lots of lakes and stuff. Those lakes and even the Great Lakes were carved out by the glaciers. If you go up into Canada, on this side of the Rockies, all that has been just literally flattened, and you can just drive for miles. It's just perfectly flat and great for farming, but not very exciting to look at. And all that was created by these continental glaciers about 12,000 years ago. So again, we're talking about deposition, and that's where the glaciers have left material. That's what deposition means. And so some of that material gets left as the glaciers are moving, and that's where we see some of those boulders and things. Some of it gets left at the end, what we call these moraines, where literally the glacier was acting like a bulldozer, and then all of a sudden the bulldozer stopped, and whatever was in front of the bulldozer, it sort of remained. That's these moraines that we're talking about, and important that we live literally literally on a moraine, right? And so your book goes into some of that detail here about what that deposition looks like. And this is the kind of evidence we can see around us. If you know what to look for, you can find this stuff. So a lot of times you may see a hill, and we'll see some pictures of this here in just a second. Here we go. You'll see kind of a hill, and you kind of think of this as just a normal, this is just a normal rock outcropping, right, with some layering where we'd see sedimentation, that sort of thing. That's kind of a normal thing. But if you look carefully, you see these boulders. They don't belong there, right? If this was normal sedimentation, these boulders would be somewhere else. They wouldn't be here. But if this was caused by something pushing all this stuff, literally not sorting it out. Remember, when we talked about erosion from like a stream or something, the bigger stuff would stay at the top, and the smaller stuff would make its way farther and farther and farther down the stream. Here we have big stuff and little stuff all mixed in together, like a big jumbled mess. And so this is the sorting that we would see and understand that this is caused by glaciers, not by liquid deposition, not by a river or a stream depositing material here. And again, these erratics, just boulders that don't belong there, belong in this area, and they just kind of are there. And so that's kind of some clues to some of that sort of thing. And you do see some of that around here. You see things that just, like I said, rocks stuck in places where they shouldn't be, and that would be a big clue that, in fact, this stuff doesn't belong here. Here's a picture then of New York, Long Island. There's New York City down here. Here's Cape Cod. And all this is where the glaciers literally stopped and just pushed all this material. Cape Cod is literally built on just dumped material. When the glacier came down, it stopped right there, and whatever was being plowed ahead of it just literally was there. And so that's kind of interesting. Again, if you know what you're looking for, it's a very interesting thing thing to see on a map. These lakes we talked about a little bit. Again, you see these in Minnesota all over the place. Minnesota again is called the land of 10,000 lakes, and all those little lakes were caused by glaciers kind of gouging out holes in the ground. And of course, when the glaciers melted, the lakes filled up with water, and it's a great place to go fishing. So if you like to go fishing, go up to Minnesota and fish in some of the uh, glacier lakes up there. Here's that big picture that shows some of the features that they've just been talking about. Really good to see and to understand how this all kind of works. Uh, your book talks a little bit about the fact that these glaciers actually cause enough weight on the Earth's crust that they would push down on the crust. And of course, when they melted, the crust would rebound back. And so we're still, literally 12,000 years later, we're still seeing this kind of rebound effect, uplifting of soil caused by the fact that it's kind of like if you slept on a bed and then you got up out of the bed, you see this kind of a depression. And over time, the bed sort of rebounds back. Uh, uh, um, and we're still seeing that today in certain places. Um, it had a big effect on lakes and rivers. It had a big effect on human habitation. In other words, we think that a lot of human habitation happened in North America because when all that water was locked up in ice, right, it would have made the ocean levels to go down and created this bridge from Siberia to Alaska. And so a lot of the theories are that a lot of the people that Native Americans that were living in North America when the Europeans came across on these land bridges, either caused by ice or caused by lower ocean levels. And then there's all kinds of stories about um, people in the Philippines and Southeast Asia and all that were all what they are now. They're all islands, right? But during this glaciation period, they all would have been connected, and so people could have walked out onto these islands. And then when the glaciers receded and the water came back in the ocean and filled up, that isthmus or that land bridge is gone. And now we have islands. So that's, again, quite a theory. Here's this idea of the fact that this last glaciation caused a lot of these rivers to change. In other words, before the glaciation, we had rivers running north. So everything was kind of running into Hudson Bay up here from Canada and even in northern America, but then northern United States. Then when the glaciers come in, they kind of plow all this over, and now suddenly the rivers are moving south. And so if you look carefully here at this map, there is no Ohio River. there's no river here at all. The river comes because this all gets pushed down and kind of consolidated, and this river then becomes the Ohio from starting in Pittsburgh all the way down to the Mississippi. And so that kind of a little bit of interesting information about where we live, right? Um, there are other big lakes that probably formed during this time, and we see evidence of that. There were some big lakes out west that were formed before the West became more of a desert. So we've seen that in other continents like Africa. So the climate changes, and that water now, of course, is all gone, but the evidence of it is still there. And so we can tell that's what was there at one time. So this last ice age, we call it the Pleistocene ice age because it happened during the Pleistocene period of history. And again, it was about 12,000 years ago. Now, if you think about, again, human history, there were modern humans on the planet, very modern humans, as a matter of fact. Um, and so these indigenous people, this is about the time, a little bit before that, is where the last of the sort of dead branches of humans disappear. In other words, the last to go um, are the Neanderthals. They're going to disappear in Europe about this time, and so after the Ice Age comes and goes, the only humanoids left, the only uh, sapiens left are the Homo sapiens, the modern humans. And so then they, of course, become indigenous people in not only North America, but they're eventually going to create, again, begin moving and living in cities, which, if you stop and think about it, cities are basically just large families. So people have been living in family groups, tribes, for a long time, but now suddenly these tribes are getting bigger. We're no longer hunters and gatherers, right? We're beginning to learn that we don't have to gather anymore. We can actually plant seeds and harvest things. We don't have to go out and look for things. We can actually grow them. And this is the beginning of agriculture. And then, of course, animals, we begin to domesticate certain animals so that we don't have to go out and hunt them and look for them. Now uh, we have domesticated breeds. We can just uh, raise them, right, and slaughter them as we need them. And so this is the beginning of what we think of as modern civilization. And so this all literally happens after the Ice Age. So in effect, you're going to see in a minute, this is a pattern. We're actually living in a warm spell, from the standpoint of the Earth, a very short warm spell in terms of years. 12,000, 20,000, 40,000 years in terms of the Earth is a blink of the eye, right? For humans, it's a pretty big deal. But for the Earth itself and for the patterns of the Earth, it's really just almost nothing. And we'll see that here in just a little bit. Places to go if you want to see glaciers. Again, if you're planning a trip, that would be a great place to go and see some glaciers. Um, Here we can start to see um, the timing of this. And again, we're going to look at sort of a bigger map here in just a minute, or at least a bigger model here in just a minute, to see how this all worked. Here we see glaciers in Europe. And of course, there were animals that lived during this time that then, after the glaciation, when modern humans, sort of began to dominate the area, literally mammoths were probably some of the first animals that humans hunted to extinction. Here's kind of the map I wanted to show you. So we know that the Pleistocene glaciation, the glaciers, were the last ones, but they certainly weren't the only ones. Here you can see glaciations over millions of years. These are big ones that have happened over time. Anywhere there's a blue dot here, that probably are temperatures low enough to have caused a glaciation. But let's just look at, here's modern time. There's the dinosaurs disappearing, right? And during the dinosaur period, notice how warm it is. And so there's a lot of carbon dioxide in the air. It's very warm. There's no glaciers at all. This is actually the beginning of the dinosaurs here. So they're all living in this time where it's very warm. They're going to disappear. And then this cycle of glaciation starts again. Well, here is this section of time, a little over a million and a half years, right? Look at all the different glacier time. These are all times when glaciers kind of came and went. Some of them bigger than others. Here's some very large, probably a large amount of area was covered by glaciers. So here's the one. This is the last one, right? This is the Pleistocene glaciation right here. Look at all the ones before it, and so it's a fairly big glaciation period. It's fairly long, and then here is today, right there. There is today, right here. So you can see we're in one of these warm spikes, but you can see what happens, right? And you can see that, will glaciers come back? Well, yeah. Yeah, in a few thousand years, the glaciers will probably be back. You and I will probably be gone. Um, but it is definitely a cycle, and depending on how bad climate change happens, it may delay it, but it's quite possible that these glaciers will come back. So, what causes these swings? Why is it sometimes warm, sometimes cold? Well, here's some of these explanations. One of them is called orbital eccentricity. In other words, as we go around the sun, our orbit can wobble a little bit, can change a little bit. Sometimes we're closer to the sun, sometimes we're farther away. Sometimes our orbit is more of a circle, sometimes it's more of an ellipse. So those can make changes. The tilt of the axis, so we know we're tilted about 23 degrees or so. but that tilt can wobble a little bit. And so sometimes we're a little more like 22 and a half, 22. Sometimes we're more 24 and a half, 25. And so that can change whether seasons are extremely hot or extremely cold, right? Also, there's a what's called the precession of Earth's axis. In other words, if you've ever seen a top, if you've ever spun a top and you watch the top, it's spinning very fast, but as it's beginning to slow down, you can see the top kind of wobble a little bit. And that's this precession we're talking about. And that precession can happen over about 2,300 years, which half, of course, is about 12. And so that wobble is probably what's causing most of the glaciations we've seen lately. Milankovitch was the scientist who kind of discovered some of these ideas, and so we call these the Milankovitch cycles, and other types of things that can happen. Here, your book shows you a little bit more modeling as to what these wobbles look like and what that eccentricity looks like in the Earth's atmosphere. There's other things that can cause it too, and of course, the big unknown is our changing of the climate. Humans are new on the scene, and the Earth has not seen this variable before, and so it's hard to tell if this is going to delay the next ice age, if it's going to completely, stop these cycles. Um, it may have a um, yeah, an effect where it makes it even worse. Who knows? So we're all kind of living in an interesting experiment where this has never happened before, and we're going to wait and see, excuse me, what's going to happen. And so that's what your book is kind of talking about here. We've already seen some of these cycles kind of repeating to a certain point. There was the Little Ice Age that happened in the 1820s, 1850s, excuse me. And then the medieval warming period, and then of course today a really warming period. We won't see um, um, some of this freezing that we would have seen before. I mean, there are stories, pictures, and stories of here in Louisville back before refrigerators. You had an ice box, and so there are buildings right now on Main Street. A couple of them left. One of them's about gone, but there's a little bit of it left. These were ice houses, and literally, what people would do, the Ohio River would freeze over. It would freeze, with ice that was a couple feet thick, and so guys would go out there with big saws. There's pictures of people going out there with big saws and cutting big blocks of ice. They would haul them into these buildings, insulate them with sawdust, and then in the summertime, that was the ice that you used in your ice box. It was a guy who drove around in a truck, or I guess he had a horse and a cart at that time, and would deliver ice, and you'd put it in your ice box. That would keep your food cold for a while, for a few days, and then he'd have to come back and bring you more ice. And so, that doesn't happen anymore, and it's all because of what we're going to talk about in the next chapter. So again, this is a fascinating little subject. Here are your review questions here on page something, something, something. I lost the page number here. Sorry. But anyway, great chapter to look at again, because it's like plate tectonics in that it's nothing we can actually see. It happens so slowly over time, but we see all the evidence. And I will see you next time.